It is integral 0 to L and fx and cos of n pi x by L. Again, apply the same technique UV rule and solve the example. Then after finding an, just put the value of a naught and an, and that gives you the half range cosine series. Similarly, if it is asked to find half range sine series, then the sine series formula is this summation bn sin n pi x by L. So there you just have to substitute the bn. For that, the formula is 2 by L, 0 to L, fx sin n pi x by L. Put the value of fx, integrate using UV rule. Whatever answer you get, you replace it at the place of bn, and that gives you the half range Fourier sine series. Okay, so this is the technique, and using this technique I have solved it for Lx minus x square from 0 to L, and here it is asked for pi x minus x square from 0 to pi. So this question was given to you for homework, and these three questions, three different questions, all should attempt, all should try and the answers, right? So I'm not going to discuss anything about this example number 7, 6 and 7. Today I'll start directly with the harmonic analysis now. Okay, our today's topic is harmonic analysis. Now see, whatever Fourier series we have seen, that is for the given periodic function fx, right? But in practical situations, you may not have the periodic functions available with you, right? And instead of that, there may be certain values. Okay, means the table values are provided to you. So in practical problems, if these observations are available and still you are interested in deriving the Fourier series, then we apply the harmonic analysis. Okay, so in many practical problems, instead of the function table of observation may be available. Okay, table of observation may be available. In this case, we cannot find Fourier series. We cannot find Fourier series using the integration. Okay. So in this case, but here I can write it like that. But here we can get or we can find approximate values of the Fourier coefficients, not all, but first few coefficients. You can find all, but there is a limit, isn't it? Practically, if you are solving by approximate integration. By approximate integration. Okay, that is, so let fx be a function defined in, let us take the interval 0 to 2 pi. Let us derive the formula for 0 to 2 pi. Okay, now it is be a periodic function with period 2 pi. Okay, a periodic function with period 2 pi. So now your L value is pi here, isn't it? L value is pi here. So you know that fx is, what do you know? We know that fx is a naught by 2 plus summation an cos nx plus bn sin nx, which is nothing but a naught by 2, okay, plus a1 cos x plus b1 sin x. This is the first term. Then a2 cos 2x plus b2 sin 2x. This is the second term. Plus, okay, now let me write down that term in one line, so that because there is some definition related to that term. A2 cos 2x plus b2 sin 2x. Next is a3 cos 3x plus b3 sin 3x, and so on. Okay. So here, this first term, this is called as the first harmonic. Okay, when you find the coefficients using numerical techniques, this is called as the first harmonic. This is called as the second harmonic. Okay, this is the third harmonic. And this is the constant term in the Fourier series, right? So now, given the values xi by I, so let xi by I, these table values are provided to you, be the set of values, right? And here important thing is where xi are equally spaced. Means what? That is x1 minus x0, then x2 minus x1, x3 minus x2. All these differences are same. Okay, these are called as equispaced values. For example, I can draw a line here, right? This is a line, and suppose you have x0 at this position, x1 here, x2 here, x3, and so on. And last term is say xm, right? Your interval length is actually 0 to 2 pi. So that you are dividing it into so many parts. These are your given values, right? Now I am saying that each part has equal length, right? Each part has equal length. So this is the first part, this is the second part, this is the third part. So can you tell me here, if I am having xm minus 1, how many parts I am having in this particular interval? Yes. How many parts I am having in this interval? Up to x there are 3 parts. So up to xm, how many parts will be there? Up to x1 there is 1 part, right? Up to x2 there are 2 parts. Up to x3 there are 3 parts. Up to x4 4 parts. Here m minus 1 parts, and up to here there will be m parts, not infinite. Getting my point? So there are m parts, right? Thus there are m parts of 0 to 2 pi. So can you tell me what is the length of each subinterval? Length of each subinterval is, yes, total length is 2 pi and there are m parts. So what is the length of each part? My question is very simple. Correct, oh, correct, Pratik. They are equally spaced. Means they are at equal positions. Okay, so each subinterval has length. Correct. Most of you have given the correct answer. 2 pi by m, right? So what I can say, I have a relation. X1 is nothing but x0 plus 2 pi by m, right? What is your x2? It is x1 plus 2 pi by m, which I can write as x0 plus 2 times 2 pi by m. right? So likewise, I have all the values. X3 is say x2 plus 2 pi by m, etc. So on. Okay. Now I'm going to use this concept to get the or derive the formula, which is approximate formula for the integration. Okay. So let us derive the formula. Let us derive the formulae for these Fourier coefficients, right? Okay. Now we know that A naught is 1 by L, but now you know that L is pi, then 0 to 2 pi, right? Complete length of the interval fx dx. This is the formula for A naught, right? This is for continuous function. Okay, we can integrate the continuous function. But for discrete functions, now what I'll have to do? I have to replace, if you remember, the integration is nothing but summation. Integration symbol I'll replace by summation sign. This 1 by pi will be as it is. Fx I'll denote by y, right? Because for each x I have a y value, so I'll replace it by yi. Then this dx I'll replace by the length of the subinterval. Okay, so the length of the subinterval is 2 pi by. Okay, and I going from say 1 2 or 0 to 0 to 0 to m minus 1. Okay, or you can write 1 to m. So like this, we'll have to consider all the values. So now this gives this 1 by pi is outside, then pi by 2 pi by m also I can take outside because it is a constant, and summation yi goes from 0 to m minus 1. So this gives 2 upon m into summation I goes from 0 to m minus 1. So I can write it as 2 into summation yi upon m, and summation yi upon m is nothing but average of y values. Total y values, I'm taking the total of y values and dividing by the number of observations, right? So this is 2 into average of y values. So what is your formula for A naught? Just remember this formula. Formula for A naught is 2 into average of y values. 2 into average of y values, right? Now, similarly, we'll derive the formula for AN and BN. Okay. So, similarly, first of all, tell me whether you have understood how I have derived this formula. So, similarly, Students, am I audible to you? Please reply. There was some connectivity problem. Okay, thank you. So I hope the formula for harmonic analysis is clear to you. Okay, now which concept we have used here to derive this formula? See, students, the area under any function, if you are calculating, what do? You divide that particular area into small parts, right? And then you measure the area of each sub rectangle, and then you take the summation. Okay. And as you increase the number of rectangles here, you get more and more accurate answer, right? So it is actually summation of areas, but when you take limit of all the areas as n goes to infinity, means the number of subparts here the number of subparts as it increases, that means as it goes to infinity, the summation becomes integral, right? So actually, see, the integral symbol is like that of s, means summation. So infinite summation is nothing but integration. That is the simple thing which I have used here to derive it. Okay, so let me rub it. Right. So what we have now, similarly, an formula. Now, can anybody tell me what is formula for an? What is formula for an? The formula for an is 1 upon pi integral 0 to 2 pi fx and cos nx dx. I'm not writing L here because I know that L is pi. I'm considering the particular case L equal to pi for my examples, right? So again, if I replace this formula by the numerical technique, so what it will be for the discrete function? This is for continuous function. For continuous function, but for discrete functions, a will be 1 upon pi. Okay. Now again, the integration will be replaced by summation symbol, right? Then fx is replaced by yi, cos of nx, but I'll write nxi. I have to consider all values. I going from 1 to 0 to m minus 1. And d of xi is 2 pi by m. That is the length of the subinterval, right? Length of the subinterval. So what does it give? It gives 1 upon pi, then 2 pi by m is outside, and summation yi cos of nxi, right? I is from 0 to m minus 1. Pi getting cancelled. So it is 2 into summation. You can write it in short like this. It is understood that you are taking sum over I, and it is summation y cos nx upon m. So an formula is nothing but 2 into average of y cos nx values, right? So it is 2 into average of y cos nx values, right? So similarly, also we have, I'll not give it now, bn is 2 into average of, so before writing 2 into average, I'll write the formula 2 into y sine nx upon m. This is the formula, that is bn is 2 into average of y sine nx values, right? So harmonic analysis is very simple. It is very simple. You should have these three formulae with you, right? Which three formulae? A naught is 2 into average of y values. Then an is 2 into average of y cos nx values. And then next is bn equal to 2 into average of y sine nx values. Okay. Write down these three formulae in your notebook. If you are not able to write everything, I'll share it later on, but you write down the formula which is required to solve the example. Okay. So I'll summarize all the formulae and write them together. So for Fourier series, in 0 to 2 pi with period pi, period 2 pi, that is L equal to pi value we take, isn't it? A naught is 2 into summation y by m. An is 2 into summation y cos nx by m. And Bn is 2 into summation y sin nx upon m. So depending on which harmonic you need, you have to put the value of n. Okay. So let me give you an example. Now see here also students, you have the half range Fourier series, but that part we'll discuss afterwards. Okay. So example number 1. On full range series we are solving. The following values of y gives the displacement in inches of a certain machine machine part for the rotation x of a flywheel. Okay. The question is expand y in terms of Fourier series. Y in terms of up to second harmonic.